I had to scrap this video because I got interrupted, so I'm not going to redo all my work. But what I was doing before I scrapped it is I was writing out what this means. This is 3 factorial over 4 to the n. And I was going over factorial. You may not remember doing it in IXL. There's a button on a calculator. Like if you don't know that 3 factorial is 1 times 2 times 3, you can hit 3, math, number, scroll over to probability, and there's a factorial key. It's 6. All right. 4 factorial would be 4 times 3 times 2 times 1, which is 24. So the first term would be 1 factorial over 4 to the first, which is a quarter. The second term is 2 factorial over 4 squared, which is 2/16, which is an eighth. The third term is 3 factorial over 4 cubed, and if you don't trust my math here, it's going to hit divided by 4 to the third power. It's at decimal 0.09375. And it reduces down to 3/32. I hadn't reduced it yet. 3/32. The next guy is 4 factorial over 4 to the fourth, which is kind of funny. 4 math. It's the same thing. So that's what the pattern is. The next guy, by the way, is 5 factorial. Whoops. Sitting pretty over 4 to the fifth. It changed, didn't it? I didn't actually expect it to change. What I'm doing here is I'm writing out a couple of things and seeing if I can figure out what the pattern might be. It's kind of interesting that those two repeated. That bothers me a little bit. What you need to do is you need to go back and think about your knowledge of recursion and see if any of these formulas actually work. That's what you need to try to figure out. Do any of these actually work? And the fact that there's repetition bothers me, but it might just be me. That whole repetition is bothering me. Whichever one of these formulas work, unless I have screwed up here somehow, which I don't think I have, they have to create these terms. Those are the key. If these formulas work, they have to create these terms right here, third and fourth position. All right, number 12 is find an expression for the determinant of the matrix A. And that little funny looking thing there, which I probably cannot draw, is the Greek letter lambda. Where you got your L from? It's the Greek letter lambda. And I never did determinants with you guys. Wasn't in your standards, never did them with them. They're not even in your standards in precalculus. They should be, but they're not. Precalculus is still going under the assumption that we taught matrices in Algebra 2, and we did not teach matrices in Algebra 2. But anyways, you don't have no idea how to do a determinant. You do have the ability to make up a number for lambda. And I'm just going to let lambda be 3. Why not? I go to second matrix, scroll on over to edit. That's a 3 by 3 matrix. She has 3 rows and 3 columns. And everywhere I see a lambda, I'm going to put a 3. And I'm about to be interrupted again. What's up, Coach K? No, I'm just recording a video.
Oh, okay.
Let me pause it. No, I'll pause it. It's okay. You got something to do.
I got a quick question. We'll take 5 seconds.
All right, so that took so long, my calculator turned off. Anyways, I went to second matrix. Everywhere I saw lambda, I put a 3 in place. I'm just checking 3, 2, 0, 0, 3 plus 1 is 4. You can literally type 3 plus 1, by the way, because if you don't know, you don't know. And bam. So now I'm going to quit out. Back to matrix math, DET. If you press this, the calculator doesn't go boom. Need an argument. Second matrix A. It's 30. So I found that the determinant is equal to 30. The right equation also generates 30. That's if lambda is 3. All right, write an equation for the line that goes to the center of the circle, x squared plus y squared minus 2x plus 4y equals 4, and is perpendicular to the line 3x plus y equals 7. So what I need to know is I need to know the center of the circle. So I'm going to rearrange some stuff here. And I'm going to use that 6,000-year-old technique called complete the square. And I'm not going to show you any of the steps in it. Well, I guess I got to show some of it. I took half of -2, which is -1. I squared it, got a 1, added it to both sides. I took half of 4, which is 2. I squared it, got 4, added to both sides. Right-hand side adds up to a nice number called 9. This factors as x minus 1 squared. That factors as y plus 2 squared. So my center is at 1, -2. And I'm going to be perpendicular to this line. By the way, this line, if you do mx plus b, is -3x plus 7. The perpendicular slope is 1/3. You got a slope, you got a point. Figure the rest out. 19. The second and sixth terms of a geometric progression are 3/10 and 243 1/60 respectively. What is the first term? I don't know why this helps, but it helps me out tremendously. First, second, third, fourth, fifth, sixth. What happened? 20, 40, 80? You figure out the top piece. Okay? You figure out the top piece. And I don't know why that works, but just writing things out works for me. Find the angle between the two vectors, v, which is 3i minus 2j, and w, which is -i plus 4j. And you have not been taught vectors. I have to teach that next week to juniors. Something that was pulled out of standards and finally put back in. This is the ij notation. This is a component form. Don't be freaked out by this. 3, -2. This has a component form -1, 4. And this is literally the same thing as 3, -2. And this is literally the same thing as -1, 4. That's all it is. It's all it is, I swear. It's not a hard concept. So this vector starts at the origin. It goes over 3 units and down 2 units. This is vector v. Vectors have direction and magnitude. And w goes down 1. Sorry, w goes left 1. And then w goes up 4. This is what vector w looks like. All right. And your task is to find the angle between the two vectors. And I'm trying to think if I should use a formula or if we should do this a classical way. I can tell you one thing. It's not that one, it's not that one, it's not that one. Because there's 90 degrees right here. Make any sense? I don't know. There's a shortcut form of this one, which I cannot think off the top of my head. It's a component form for finding an angle between two vectors. But what you can do It's just not hard, is you can just think about triangling out each angle, which is something we should do, teach you how to fall back on easy skills. This triangle would be 3 and 2. All right, here's an angle, we'll call it theta. Theta would be the arc tangent. I'll make sure I'm in degree mode too because the answers are in degrees. Theta would be the arc tangent of 2/3, 33.69 degrees. I can do the same thing over here. Think about that point being triangled out. It was back 1 and up 4. And just throw theta in the corner there. And theta is the arc tangent of a quarter. I got another interruption. 14.04 degrees. So what I've given you here is I've given you these two, and I've given you that 90. So that ought to be enough to finish it off. Looks pretty close. So yeah, I think it's enough. The points of intersection on the graph of xy equals 20 and x squared plus y squared is 41 are joined to form a rectangle. Find the area of the rectangle. I bet this isn't funny. Or I bet this is not a fun problem. What does x times y look like? Y equals 20 over x. That is a fugly graph. This is a circle centered at the origin with a radius being the square root of 41. I literally have no desire to draw this by hand. So I'm going to use y equals, here's y1. To do the circle, what I'm going to have to do is I'm going to have to move this over. Y squared is 41 minus x squared, and y is either plus or minus the root of 41 minus x squared. And that'll be y2 and 3 respectively. I screwed up saying it. So what do we have here? We have 20 over x for y1. We have the square root of 41 minus x to the second for y2. And we have the negative square root of 41 minus x to the second for y3. You do a good old zoom 6. Now, what did they just say? They said the points of intersection of these graphs are joined to form a rectangle. So second trace 5. Watch them come out to be pretty numbers. I would be amazed, but I think they are going to be pretty numbers. Oh, this is something I don't do too often. There's my cursor. I want it on the black line, enter, enter. So -5, -4. I told you they'd come out to be nice numbers. Somebody spent some time working on this. That one's ugly. -3.788, -5.28. The other one's at 4.5. That one's at 5.4. Huh. I question that. Yeah. So the numbers weren't too bad. It's a sideways rectangle. But there's your ordered pairs. You know, I could have done this algebraically. I don't know why I didn't do that. But anyways, there's your ordered pairs. You know how to find the area of a rectangle. You need to find your length and your width. That's what you need to do. So you do that. And figure it out. I'll stop this video so I can do one with the actual test questions. I burned way too much time on that.